Hey everybody, it is really good to be back with you. I know it has been a while since I've made a video. I believe I mentioned earlier, right? I was going back to school trying to work on a master's in software development and just have not had much time, but on a little break from classes for a few weeks. And I wanted to get back and do a few more of these, and especially this one, right? So this is, in my opinion, hold on, my watch is beeping at me. This, in my opinion, dependency injection, right? Like this is the number one thing I think you can do as a developer to create like good, awesome, loosely coupled code. And it's just a technique. It's a technique. We talked in an earlier video about dependency inversion. Dependency injection is it's a technique. It's how do we do that? What's the best way to implement dependency inversion is a good way to think about it. So I think this is going to really be a great video. And I think there's going to be hopefully everybody learns a lot from watching this. And let's switch over to IntelliJ, right? So I already ahead of time created a few classes, stubbed a few things out, and we're just going to kind of continue on with what we did last time, I believe, in dependency inversion. It's been a while, where we had like a shopping cart class and a payment method class. Because I think a great example is something where you don't really know, say, what type of algorithm, what type of object you need until runtime, right? Maybe until a user does something. And really, again, we're kind of implementing the strategy pattern here at the same time. Another time, maybe I'll make a video on the actual strategy pattern itself. But so right now, we're just going to talk about how do we take our shopping cart and our shopping cart. So, like any other app, right? People are going to put stuff in it and they need to pay. So we are just going to worry about that payment. So right now we have this shopping cart class, right? And it has a pay method. So let's just say the only thing we have is I stubbed out a few classes ahead of time. So let's just say we have credit card equals new credit card. Okay. And then we'll say card dot submit payment. Made a couple things ahead of time. So right now, we have a hard dependency. This is a hard dependency in our shopping cart class. This means this class cannot be created. It cannot be tested. And this is important. It cannot be tested even without an instance of the credit card class. It is tightly coupled to that class. And so one of the things we'll get into, this is probably another video, but one of the nice things when we talk about testing, the dependency injection really allows us to do is mocking. And that maybe will start to make sense to you as we get into this video. But so right now we have this hard dependency in our shopping cart class. We are dependent on credit card. And obviously, so business requirements are going to change, a month from now. Maybe right now we only take credit cards. But, we need to take PayPal. We need to take debit cards. We need to take cryptocurrency. The list goes on, right? And what we really don't want to do, is violate, I would say, the open and closed principle, right? Like our software should be closed for modification, but open for extension. So what we don't want to do, and I feel like I see way too much of this in a lot of the Salesforce code bases I look at, right? We'll say, if, I don't have a parameter in both, if credit card, right? Do credit card stuff, right? Else, if, right? Do debit card stuff. Not what we want, and especially when these start to get complex, and we start to have ifs and ands and ors. This is bad practice. This is hard dependencies. This makes code that is hard to modify, hard to extend, hard to maintain, and just really hard to test. Very, very hard to test because we have all of these dependencies. So now we can't test our shopping cart class without bringing, say, the debit card class, the credit card class, all these other things in with it. So what we want to do is implement some dependency injection. So I'm just going to go get rid of all of this. We don't need any of that. I'm going to get rid of it all. And dependency injection is the only real difference from we talked about. So earlier when we talked about dependency inversion, right? So I've already created this iPayment service interface, right? iPayment service, we could say equals new credit card. And really, yeah, IntelliJ is going to throw a big red squiggly under there because I actually haven't implemented this yet. So this would be a step in the right direction. We're now no longer dependent on credit card, but we still have this step. So we do have that. We are now programming to a super type. We're programming to this interface, not to a particular implementation. But we still have this hard dependency right here in our shopping cart class. And that's what we're going to get rid of today. That's the next step. So this is inversion of control, and we already saw that. Dependency injection is the next step and lets us get rid of this new keyword inside we call our client class. Because the phrase I like to say is new is glue. Once you have new in there, those classes are stuck together. So let's get rid of that. We don't want it. So dependency injection, there's a couple. So here's what we need, right? You have you need your client, right? This is our shopping cart class. We need some sort of a service. And these are going to be our payment classes, right? Credit card, PayPal, these are our service classes. And we need we need some sort of an injector, right? That's the real difference between dependency inversion is dependency injection. Now we have this injector. So let's talk about how do we implement that. So first off, let me go and open that up. We're going to start with, we have iPayment service. Right? So we are going to do this with an interface. And I don't know why that's not called iPayment service. Right? There we go. That's what we want. I'm going to delete this class real quick. Bear with me. Not sure how that got in there. Okay. All right, so we have our iPayment service interface. And let's have it implement a method that's going to return a Boolean called submit payment. Oh, we don't even need those curly braces, right? Because an interface method does not have a body. Hold on. That's my problem, right? So I was trying to figure out why is it throwing a red squiggly under there. Because I didn't declare this as an interface for some reason. So let's do that. Public interface. There we go. Perfect. Okay. Public Boolean submit payment. That's our interface. Now let's go back to our shopping cart class. And we are going to use composition. Remember, we talked about preferring composition to inheritance. So we're going to say all of our payment service, right? So our shopping cart now has, remember, composition. It's a class composed of other classes. It has the iPayment service class. Next thing we need to do to implement our dependency injection, and we're going to start what we call constructor injection, and that'll be clear in a minute, is we're going to go to our credit card. We're going to go to these classes. I'm going to say implements iPayment service. Because if you remember, if we want to use an interface, the concrete classes have to use the implements keyword. And, you've seen that in Apex, right? You've done implements queuable, implements batchable, right? All that. This is all an interface is. Those are the ones that Salesforce provides to you as language features, but you can make your own. PayPal. So let's go. As you can see, I stubbed some of these, or I already wrote some of these out, and I gave them the submit payment method. Implements iPayment service. And you can see we're just doing trivial stuff here, right? Because we're just going to talk about how dependency injection works. So there's just a debug statement, and it's going to return true no matter what. All right. Crypto, right? Because we're going to take Bitcoin. We're going to take Dogecoin. Implements iPayment service. There we go. And last one, debit card. We're going to write this one out together. implements iPayment service. Very nice feature of Illuminated Cloud and IntelliJ is this code completion for you. So I just want to right, bam, I just hit Control I and I get that. Now we'll just do a system debug so we can get some text in our console. Debit card payment. All right. Let's see if this will all compile. I wrote some of this out ahead of time and I did not compile anything, so hopefully it all works. I may need to get things into the appropriate sequences here. Oh, we don't want Payment Factory yet, so you didn't even see that. We're hiding that one for later. We're supposed to see that class yet. All right. This is the challenge of trying to write some of the boilerplate out ahead of the video, is having to go back through and make sure some of this compiles, right? But I think looks like we're in pretty good shape. All right, and last one, I think we're okay. Cool. All right, let's get back to our shopping cart. Oh, let's compile shopping cart. We got red squigglies. All right, so there's two ways we can implement dependency injection. So we've got our client class here. You saw our injectors or our service class. Now we need to do the actual injector. And we are going to, we're going to talk about the two ones you're going to do most often: constructor injection and setter injection. Okay. So now we're going to just create a constructor. All right. So we're going to say public shopping cart. I'm going to say in our shopping cart, we need to take a payment service, and this dot payment service equals service. Right. And down in our pay method, so what we're actually going to do is we're going to delegate the pay, right? So we're going to say payment service dot submit payment. Because, right, it's an interface. It's a super type. So we know that anything that comes in there is going to have that. Anything that is a subclass of iPayment service is going to have that submit payment method, right? So let's compile that, and we'll just run it in anonymous Apex. See what we get. All right. Let's give ourselves a little more. So what we want to do, right, is we're going to say shopping cart equals new shopping cart. And because our dependency there is in the constructor, right, we can say new credit card. And then let's do cart.pay. That was the name of it. All right, let's run it, see what we get. Debug only. Submitting a credit card payment. Let's swap that out for crypto. Submitting a crypto payment. So that is that's all there is to it. That is constructor injection. So somewhere else, right? We are actually going there, a main method, some other place, a factory is creating that dependency, right? And it's injecting it into the constructor at runtime. Now, another way to solve this is with what is called setter injection. So let's do, we're just going to write a method, right? Because I want to leave both of them here. So we're going to say public set payment. Service. Payment service. All right. So now we're injecting it through a setter. All right. Now let's get that out of the constructor. Right. Or this actually won't compile for me, will it? We don't need the constructor at all anymore because we're not using it. Public. What's going on here? Invalid constructor name. Oh, public. Sorry, I don't know what I'm doing now. Thank goodness for Control Z, huh? I'm going to Control S and compile that. And, sorry, let's go back to Anonymous Apex. If you're still bearing with me at this point, you're fantastic. Thanks for putting up with my incompetence in these videos. All right, shopping cart equals new shopping cart. Now we're going to say cart.setPayment. And remember, it takes any, so let's give it a crypto. New crypto. And now, cart.pay, right? See if it works. Submitting a crypto payment. What if we go and we do debit card? Submitting a debit card payment, right? That's all there is to it. Now, another way that I like to do this is a little bit through, sometimes is as a factory method, right? So putting a factory in the constructor, and I will show you this technique. And if you don't like it or you do like it, let me know in the comments. All right, so we've got our setter. I'm going to go back. I'm going to give us a constructor again. And I'm going to leave that as a no argument constructor because I kind of like no argument constructors. I'm going to say this payment service equals payment factory dot get payment service. Although we actually are going to need what I will show you is accepted payments. Type. Payment type. Okay. I don't know if I've showed these before. I really do like to use enums, enumerated values in programming, is a way to maintain type safety. Actually, the more you could kind of get away from strings, etc., the better off I think you will be. So I'm just going to, I think I've got this on the, hey, there's the enums, right? This is all they are. Go take a look at the docs later. Enum classes are pretty darn easy to make, right? You're just going to you want days of the week, something like that. But it gives you that extra little bit of type safety versus passing those magic strings around inside your code base, which are, strings cause problems. So let's go back to our factory now. And so we've got this payment factory, and it has a static method that returns an iPayment service, get payment service. And so we pass in one of our enums, and when credit card, I'm going to say return. Let's do this one together. Return new credit card. All right. When debit card, right? Return new debit card. When crypto, return new crypto. what was our last one? We did PayPal. I don't think we've even tested that one yet. We're in PayPal. Let's say return no PayPal. All right. And then we'll just, for some reason we ever made it down there, we'll just say we'll return it. Now let's compile that. And while this compiles, I'm going to enjoy a delicious beverage from my sponsor, Polar Seltzer. And I'm not sponsored at all, but Polar, made right here in Worcester, Massachusetts. Be happy to have a sponsor if you're looking. All right, what's going on? Why did that not work? Is it a compiling issue? Let's go to our accepted payments. All right, back to our payment factory. There we go. All right, the joys of Apex, right? Stuff gets out of sync so easily. Okay, so now let's go back to our shopping cart class. Let's compile that one again. And there's a couple ways we could do this, right? So now we're just going to inject it this way. All right, so let's go back to our anonymous Apex. And shopping cart. We'll just get rid of that. Equals new shopping cart. And this particular implementation technique, we'll say, is payments.paypal. Yeah, that's what. All right. We're going to test PayPal because we haven't done that yet. Now we're going to say cart.pay. Submitted a PayPal payment. Boom, just like that. All right, so that can use. So there you go. There's a couple techniques that you can use to take dependency inversion and implement it with dependency injection and hopefully create much more flexible, much more maintainable, and much more testable code. Because when we talk about testing, this lets us do mocking now, right? Because now we can pass in mocks of credit card. We can pass in mocks of PayPal, right? As long as they implement that interface and we can have them return whatever we want. So that's kind of the two. Now we start to run those good, fast unit tests that you need to build to run test-driven development. Hope this is helpful. It was great finally getting back, making another video. If it was, please take a second, click like, click subscribe, and I'll see you in the next video where I think we'll actually start doing some actual patterns. Now that we've done all of these, and every pattern uses, right, a version of control, dependency injection, we're ready to do some real design patterns. I'll talk to you soon. Thank you.